Hello, aspiring Java developers. Welcome to our quick 5-minute whiteboard tutorial. Today, we are going to unravel the mysteries of two fundamental data structures in Java, the stack and the queue. Understanding these is super important for writing efficient and organized code, and they are frequently asked about in interviews, so pay close attention. We will cover what each one is, how they work with simple analogies, their core methods, and see some practical Java code examples. By the end of this video, you will have a solid grasp of when and how to use stacks and queues effectively in your Java programs. Let us begin our coding adventure. Alright, let us dive into our first data structure, the stack. Imagine a pile of plates in a cafeteria. You always add a new plate to the top, and when you want to use a plate, you take the one from the very top. This is the core principle of a stack, which operates on a last-in, first-out, or LIFO mechanism. The last item you put in is the first one you take out. In Java, the stack class provides straightforward methods. To add an item, we use push. To remove an item from the top, we use pop. And to simply look at the top item without removing it, we use peek. The isEmpty method helps us check if the stack has any elements. Understanding these operations is key to effectively using a stack. Now, let us shift our focus to the queue. If a stack is like a pile of plates, a queue is like a line of people waiting for a bus. The first person to join the line is the first person to get on the bus. This is known as first in, first out, or FIFO. The first item added to the queue is the first one to be removed. In Java, the queue is an interface typically implemented by linked list for common use cases. To add an element to the rear of the queue, we use offer or add. To remove an element from the front, we use poll or remove. And just like with stack, peek allows us to look at the element at the front without removing it. The isEmpty method also works here to check if the queue is empty. Let us put these concepts into action with a practical example, a simple browser history simulator. Here, we will use a stack to manage the back navigation, because when you go back, you want to revisit the page you were on * just before * your current one. That is a perfect last-in, first-out scenario. We will also use a queue to simulate the forward navigation, where pages are revisited in the order they were initially left. Notice how push adds pages to our back history stack and pop retrieves them. For forward history, we use offer to add pages to the queue and poll to retrieve them, maintaining the first-in, first-out order. This demonstrates how both data structures can work together in a real-world application. While stacks and queues are powerful, it is easy to make a few common mistakes, especially when you are starting out. One frequent error is trying to pop from an empty stack or poll from an empty queue without checking if it is empty first. This will lead to runtime errors. Always use isEmpty before attempting to remove elements. Another common pitfall is using stack when you actually need a FIFO behavior or vice versa. Remember, stack for last in, first out, and queue for first in, first out. Also, when working with queue, it is generally recommended to program to the queue interface and use linked list as the concrete implementation, like queue string myQueue is equal to new linked list. This provides more flexibility. Fantastic work, everyone. We have covered a lot in just 5 minutes. To quickly recap, stacks are last in, first out, perfect for scenarios like undo operations or browser history, using methods like push, pop, and peek. Queues are first in, first out, ideal for managing tasks in order, like print jobs or waiting lists, using methods such as offer, poll, and peek. Remember to always check if your stack or queue is empty before trying to remove elements to avoid errors. The best way to master these is by practicing. Try implementing a simple calculator or a task scheduler using stacks and queues. If you found this tutorial helpful, please give it a big thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java programming lessons. Keep coding, and I will see you in the next video.